This is Note Taker 4 on the scientific method and experimental design. On this slide, we are looking at the basic steps of the scientific method in order. Now, if you look at these, there is a logical progression for the order. Number 1, we have to have a problem or a question. Number 2, we will gather information about what we already know or what we may not already know about the problem or topic we have to question. Number 3, we're going to form a hypothesis. Number 4, we're going to perform the experiment. Number 5, while the experiment is going on, we are going to collect, record, and analyze data. And then finally, for number 6, we are going to reach a conclusion or solution, and then we are going to verify whether or not our results are valid or true. In this note taker, we will be looking at each one of these steps a little more closely. One day, I was sitting on the couch drinking a glass of milk, and I know that milk is good for us, but I was wondering, is milk good for plants? I didn't realize it, but I just stated a problem or came up with a question that we could then use the scientific method to solve. So just by wondering if, that's how we come up with problems or questions that we can use these steps to come up with a solution for. For number 2, we talked about gathering information. So before I can know the answer, I'm going to gather information about what I either know or may not know yet about what plants need to grow. So do you know anything about what plants may need to grow? Some examples might be water, sunlight, soil, and carbon dioxide. If you already knew these things, the gathering information portion is pretty easy. You're just tapping into the prior knowledge that you already had inside your brain. However, sometimes we have topics that we want to solve that are a little bit more complex or a little bit more difficult, and we may not have prior knowledge about it. For those topics, we would probably have to go to the library and use books or internet research to try to gather some information. After we have gathered information, we can now form what is called a hypothesis. A hypothesis is an educated guess or prediction. Now, the reason we put educated in the definition is because in step 2, we gathered information. So it becomes an educated prediction when we already know a little something about our topic. So the hypothesis is going to be a prediction of how our problem may be solved. Now, with our hypothesis, and all the hypotheses you'll be writing in class, they need to be in a certain format. Your hypothesis will start with the word if, and then about midway through the sentence, there will be a then. If you learned about cause and effect in English, that's kind of how these hypotheses work. The if portion of the sentence is going to have something to do with your independent variable. It's what we're testing in the experiment. The then portion of the hypothesis is going to be what our prediction is for our dependent variable or what we're measuring. So an example of a hypothesis for this experiment with the is milk good for plants can be found on the next slide. A hypothesis for this experiment might read, if I put milk in the plants, comma, then they will grow taller. The if portion refers to the different liquid that I'm putting in the plant, which will be my independent variable. The then portion of the sentence is my prediction that the plants will grow taller. That measuring of the height of the plants will be my dependent variable. It's what I'm going to measure to know if the milk makes a difference or not. After coming up with a hypothesis, we need to go about trying to prove, or sometimes disprove, what our prediction is. This is where the experiment comes in. Your experiment is a set of steps that are set up to try to prove if your hypothesis is correct. So what might a procedure look like for this experiment? My procedure needs to be very detailed, so look for details in these following steps. Step 1. Place 3 identical plants into 3 identical pots with the same type and amount of soil. Step 2. Water each plant with 100 ml of a different liquid every other day. Plant A gets water, plant B gets milk, and plant C will get Pepsi. Number 3. Place the plants in the same condition. And number 4. Measure the height of each plant at the end of the week for 4 weeks and record the measurements in the data table. Your procedures should be, again, very detailed. Anyone should be able to pick up your experimental procedures and repeat the experiment the exact same way that you did. As we learned on Note Taker 3, all of our experiments are going to have variables. We talked about an independent variable, which is what is being done different. The dependent variable is what you're going to measure, and the constant is anything in the experiment that needs to stay the same. So what might be your variables for this experiment? The independent variable for this experiment is the type of liquid that you are putting in the plants. If you look at the picture at the bottom of the front of Note Taker 4, you will see an illustration of 3 plants. One is getting water, one is getting milk, and one is getting Pepsi or soda. When you look at this picture, when you're looking for the independent variable, you're looking for what is different between each group. This is the variable that we are testing in our experiment. So again, for this experiment, it would be types of liquid. The dependent variable is going to be the data. Remember, D for dependent, D for data. It's going to be the data and measurements we make during the experiment. So what are we going to measure so that we know which liquid affects the plants the best? We're looking at the height of the plants, how tall they get. And again, your constants are anything that stays the same in the experiment. So for this experiment, we kept the type of plant the same, the type of flower pot, the same amount and type of soil, the amount of sun, the temperature the plant is kept in, the amount of liquid each plant is getting. These would all be constants. If you remember from Note Taker 3, you may have more than one dependent variable, many constants, but you should only ever have one independent variable per experiment. Also, when we are setting up our groups for the experiment, if at all possible, you should have a group that is not affected by what you have changed, what you are testing, called the independent variable. This is the group that is going to get normal conditions. So in this picture, which one of these plants is the control group, the group that is getting the normal conditions? If you said Group A, you are correct. Group A is getting the water, which plants normally get when they're growing outside. As you are performing the experiment, you are going to be collecting data. Data are any type of observation or measurements that you are taking during the experiment that are going to let you know whether or not your independent variable is affecting the experiment. Now with our data, we are going to record it in a nice, neat chart called a data table. So what might a data table for this experiment look like? In this data table, you will see that the left-hand column represents our independent variable, the type of liquid. And underneath, where you see type of liquid, you will see the 3 liquids listed. Across the top of the chart, you will see the height for our week 1, week 2, week 3, and week 4. That is our dependent variable, what we will be measuring. You should also, in the title bar, notice that under each week 1 height, week 2 height, and so on, you will see CM in parentheses. It is proper to put the measurement unit in the title bar like this data table shows. When our measurements are all placed in this chart, you should be able to look and see which liquid was the best for the plant. If you notice, by looking at week 4 height, the water had a height of 12.1 centimeters, which means that the plant that received the water grew the tallest. Once we have our data displayed in a data table, we can then make an illustration or picture of the data, and we call that a graph. In this class, there are only going to be 2 graphs that you are going to have to worry about making for me this year: a line graph and a bar graph. So how are you going to know which one to choose? The line graph is always going to be used to show what we call continuous data. The best way to remember this is if you're measuring something over time, use a line. And a way to remember, in history class, you should have made timelines before. So if you can remember, time and line go together. The other type of graph, bar graphs, are used to show what we call categorical data. These are data that has been collected that are going to be in categories, such as if I were to take a poll to see which types of pets are owned by the class. I would have a line for those students who own dogs, a bar for those students who own cats, and so on and so on. Another example of something I would use a bar graph for would be if I wanted to know how many of each color are in a Skittles bag. I would dump the bag of Skittles, count each color, and each color is its own category, so it would get its own bar. So, if we are measuring the height of a plant over 4 weeks, what type of graph do you think we should use to graph the data for this experiment? If you said line graph, you are correct. Here is an example of the graph for this experiment. I made separate lines for the soda, the milk, and the water. Now, when we looked at the data table, you could tell very easily which liquid was the best for plants by looking at the week 4 height measurements. Here, in a graph, it should be even easier to see what our data showed. The blue line, which represents the plant watered with the water, is the highest line in our graph. So graphs are a really quick picture to get an easy idea of what our data is telling us. Here is an example of what a bar graph may look like. Now, this bar graph does not go with this experiment that we're talking about on this note taker, but I wanted to give you an example of how to make a bar graph. You should notice that on the graphs, the independent variable should be represented on your x-axis. The dependent variable, what you're measuring, should always be represented on the y-axis of the graph. You should also notice that each of the graphs that I have shown you, plus the graphs you will be making in class, The graph should always have a title, and each of the axes, both X and Y, should have a label to explain what that graph or what that axis is showing you. Once we have analyzed our data, we can now reach a conclusion. The conclusion is the solution to the experiment. Now, unfortunately, it is not good enough to do the experiment just one time. You should have learned in both elementary school and in 6th grade that you need to repeat the experiment, and this allows you to check the validity or trueness of your experimental results. When we repeat the experiment, these are called repeated trials. You should have at least 3 repeated trials in each of the experiments you do. Once we have finished the experiment, you are going to need to write up a formal lab report. In the classroom, there is a yellow poster on the cabinet. This is the template for what your lab report must include. The write-up must have a title in the proper format. We will talk about that shortly. The hypothesis, which was the prediction you originally came up with. Do not change it. The materials that were used for the experiment. The experimental procedure in detail. The data table and the graph that you created with the data, hopefully drawn neatly with a ruler. And finally, the conclusion. When creating a title for the experiment, you need to know what your independent and dependent variables are. The title should be written in the following format. The effect of blank on blank. The first blank will represent what your independent variable is for your experiment. The second blank should be filled in with the dependent variable for your experiment. So for the plant experiment that we've been talking about on this note taker, an example of a title might read, the effect of different types of liquid on the growth of plants. The different types of liquid represents our independent variable, and the growth of plants represents the dependent variable. Because you need to know your variables before you can make the title, usually the title is done at the end of the experiment. Finally, I want to discuss with you what your proper conclusion should contain. When I grade your formal lab reports, I am looking for 3 things, at least 3 things, to be in your conclusion. If these 3 things are not in your conclusion, I will be marking that conclusion incorrect. The first thing you should do in your conclusion is to restate your hypothesis. You do not need to write it word for word again. You can actually summarize it to make it a little shorter. The second thing that needs to be in your conclusion is that you need to tell me, was your hypothesis accepted or rejected? Was it correct, proven correct with the experiment, or was it disproven, proven that it was wrong by the experiment? And finally, the third thing in your conclusion, you should explain what the actual data you collected showed. An example of a conclusion for this experiment on this note taker could be, my hypothesis that the plants would grow taller in the milk is rejected. The data showed that the plant that received water grew the tallest at week 4 with a measurement of 12.1 centimeters. Each time you write a formal lab report for me, you will need to make sure you are referring to the template on the cabinet in the room so that you know you have included everything that needs to be in there for the perfect grade.